Hi, Professor John here. This is Nikhil,
And this is James.
and we are a team for the data privacy project. So our project name is adding differential privacy to credit card client database from Taiwan in 2005. So our main goals are identify the data set of potential identify information PII to determine which statistics useful for the in the data set, and we created a system to generate differential private statistics from the dataset, and finally we automatically it will generate a PDF report when it is finished. So the dataset we have here is we have customer age, customer gender, education levels, marital status, limit balance, bill amount, pay amount. So these type of things we have in our dataset, not like other PIS like name, date of birth, SSN. We don't have that. So this data is we got from the Kaggle database set from forum. So the statistics we are using here is, so we picked only few of them. So counting the so we mainly doing the averages and counts. So counts are the most common education levels, average credit card client's age, average limit balance, and average monthly bill amount, monthly payment amount, and average bill amount. And this is the conditional statistics for average monthly bill amount credit card clients who are education levels are high school, and average monthly payments between sex male or female, and count individual marital status comparison with the default like yes or no for the married and not married singles. And we will go this privacy strategy later. First we will go to the code.
Alright, so kind of to explain how we added some differential privacy to this data set. First included some of the classic Laplace-Mech, Vec functions, percent errors. So those will be helpful further on. Included a little pinout in our code for all of the relevant columns and what they mean. So the first step, kind of generalizing the ages, what that's going to do is just give us another layer of privacy, essentially, because age is especially a very vulnerable personal identifier. We then went into our epsilon, finding our epsilon value, and we chose a smaller one here because we're doing a good amount of queries, so we want our total privacy budget at the end of the document to be somewhat low. And a low epsilon value there will help ensure that. Moving on, here are our helper functions. We're using the sparse vector technique to determine a lot of the averages in the notebook. So this function here, just passing in a column, will be great at calculating those averages. Because the sparse vector technique is pretty time complex, just in the terms that it's calculating hundreds of thousands of queries and basing the upper clipping parameter off that, also included a more time-efficient method here, using a method we used in homework 4, I believe, and that's nice for saving time. And then also, just for user interaction purposes, included some functions to calculate certain counts and add differential privacy to those. And here, just calculating our non-differentially private statistics to generate those percentage errors. Also added some methods to format the data a little. And finally, down here is where we are calculating all of the differential privacy statistics you saw a second ago. Some of them are more complex than others, but most of the time we get some pretty low percentage values and achieve a pretty decent amount of differential privacy here. I think the ending epsilon total is around 3.3. Now, hop back over. Oh, this is the section generating the PDF, which Nikhil will go over now.
Yeah. So as you see, the privacy strategy. So we use a sparse vector technique to determine the upper clipping parameter, and from that we found the noisy sums and counts, and we used the Laplace mechanism to find the averages and the counts of the statistics data set. And finally we will see the report generation. So we use these statistics, and we created a using using a special package latex km special package from the Python. So without using that we can generate a PDF. So we use that, and it generate first it generate automatically a text file, and it compiled into a PDF file. So in that we have the average queries and count queries and conditional counts and conditional averages. So let's see that PDF how it looks like. So this is the code for the generating a PDF. So we use we add all the context here, which has to be in the PDF. So without this is main function to generate a PDF. So it is first is generating the report in text, then it will compiling into the PDF file. This is the text file, and this is the final PDF file. So here if you see, it's like a real report of everything. So first we have the discussion on how it is. Actually we have done everything in the Taiwan dollar. It's not in US dollars. So privacy budget, so on statistics, average age. Because of low time, I'm just skipping this. We will submit it in the Blackboard. Please go through it. Conditional counts and conditional averages, everything. So it generates everything, and we want to show you where these references we got the references from this Kaggle, the database set, and this is our GitLab repo where we store everything, we update everything, we push pull everything here, and we manage our work here. I think that's it. If you have any questions or queries about our project, please mail us. Thank you very much.
Thanks, Joe.
Thank you.